Good morning, everyone. My name is Iqbal Hanif from Digital Next Business Department of Telkom Indonesia. On behalf of my team at Telkom, I want to present our research about ensemble learning for predicting television program rating. So here is my presentation outline, which consists of introduction, literature review, data and methodology, result, and conclusion. Let's take a look at data from Statistic Indonesia about people attention to the media, including radio, newspaper, and television around 2003 and 2018. While percentage of newspaper and reader and radio listener are declining, TV spectator are constantly increasing and reach its peak in 2018. According to these facts, television business is still prospective nowadays. So we search about more information about television industries, and we got it from medialandscapes.org about television's business overview. According to this news, Indonesia has 674 television channels, and which is 60 from them, or perhaps top 60, are owned by 12 largest media groups. And then we got the information about the revenue because Nielsen reveals that 80% of 145.5 trillion rupiahs were occupied by TV broadcasters. So it's around 115 to 120 trillion rupiah. TV advertisement business is really depend on media research, commonly known as media rating company. In Indonesia, the largest media research company is Nielsen, so they monopolize media research business in Indonesia. As digital company, we make our own media research called InRate by utilizing UseeTV data. We hope that our product can be serious contender or competitor for Nielsen. One service provided by InRate is media planning. We help clients to determine the best time and best place to run their ads for optimum result. And one important component for media planning is rating prediction. This research is aimed to make a prediction model for TV program rating. According to the Seredai and Chui from Nielsen Journal of Measurement, they have tested several algorithms for predicting rating score, and we focus on two ensemble learning algorithms that have been tested, random forest and XGBoost, or extreme gradient boosting. So next we move to the literature review. First, we need to know about rating definition. Rating is a percentage of total spectator, a person, or a household achieved by a TV program or TV channel divided by TV audience populations. For this research, we focus on TV program. So here's the formula of the rating. Next, we move to the definition of ensemble learning, which conducted several base learners and then improved their prediction accuracy by generalizing results from base learners to become a strong learners. This method is quite popular right now because this method has been proven to produce better results compared with single models such as regular decision tree. There are three types of ensemble learning. The first is bagging, which is simultaneously produce base learners from random sample. The second one is boosting, which is iteratively enhance base learners capability by adjusting weight. And the last is stacking, because it's have two or more level of base learners. For this research, we focus on bagging and boosting algorithm of ensemble learning. The first one is random forest, which is developed by Bremen in 2001. It randomly picks rows and features of variables to develop its best learners, assuming that there is no or small correlation between best learners. For regression case, the goal is minimizing mean squared generalization error for each best learners. The second algorithm is extreme gradient boosting, or XGBoost, developed by Chen and Guestrin in 2016. It iteratively developed its best learners by adds weight for misclassified error sample and subtract weight for correct classified sample. So this is quite popular right now because this algorithm is expected to handle large-scale dataset by improving the scalability of common boosting algorithm. For regression case, the goal is optimizing objective function, which is convex loss functions. Next, we move to chapter 3, which is data and methodology. As we stated before, In rate media research, utilize UseeTV data. So for this research, we sampled data start from January 2018 to September 2019. We picked 20 best programs, which is 2 of them are weekly programs, and calculate daily average rating for each program on the list. We will not reveal any program or channel name, so in this research we have an alias name for masking the real name, such as program 1 to program 20, channel A to channel F. Here is the flow for data preparation phase regarding the 3 main aspects of data preparations. So first, we sample database on data range that we stated before, and then we split feature and rating score. Feature is labeled as X, and rating score is labeled as Y. We check data incompletion, and then for incomplete raw data, we delete it. Data preparation, we create several variables using feature engineering techniques. The first technique is time series feature engineering, converting data to several numerical features such as hour, day of week, quarter, month, year, day of the month, and week of the year. The second technique is categorical feature engineering. We use most popular technique called one-hot encoding. They convert each category into variable with 1 and 0 values. Next, we move to modeling phase, and here is our modeling flow. For each algorithm, we define hyperparameter lists, then run the randomized search cross-validation with 10-fold and 10 iterations for finding the best hyperparameters. And then we evaluate the best model with the best hyperparameters with training and testing datasets. And here is our hyperparameter list. Final phase is evaluation phase. We use 3 metrics: RMSE, MAE, and MAPE. RMSE and MAE produce a decimal value, while the MAPE produce percentage value. We also determine the forecasting quality by using the MAPE value interpretation table. Next, we move to chapter 4, the results. This research was using Python programming language. For data preparation phase, we have cleared 27 rows which containing missing values, and we also made a distribution plot of all of our program rating score. For feature engineering phase, we produced 49 columns in total by transforming data and categorical features. We also split data into training and testing dataset, which is almost 9,000 rows for training dataset and 447 for testing dataset. And here is the best hyperparameters for each algorithms based on our randomized search cross-validation result. Then there are the feature importance plots for each algorithm. As we can see, each algorithm has different composition in its feature important plots. The evaluation result, we bold the algorithm that giving the best result, and as we can see in training phase, random forest give better result in all of 20 programs. According to MAPE score, random forest produce 6 programs that have rating prediction under reasonable forecasting quality threshold, which is under 50, compared with 4 programs on XGBoost algorithm. Here is the example of prediction result graph in training dataset. We took program 8, which is daily program, and program 9, which is weekly program, as samples. We can see that random forest prediction results contain less error compared with XGBoost prediction result. In dataset, random forest produce better prediction in 18 programs compared with XGBoost algorithm. According to MAPE score, random forest produce rating prediction under reasonable forecasting quality threshold in all programs compared with 16 programs in XGBoost algorithm. Random forest even produce good quality forecasting in 16 programs, which has MAPE score under 20. Here is the example of prediction on testing dataset. So we can confirm again that random forest produce prediction with less error compared with XGBoost. This is the final chapter of our presentations. In conclusions, we can conclude that random forest method produce lower RMSE and MAE scores in testing and training datasets, and also produced a better MAPE score compared with XGBoost in training and testing datasets. But prediction model capability is decreased due to a longer period, which presumably produce a large error than a short period. So what's next? We hope that this is fundamental of prediction model research in rate product, and we have a suggestion for next research. That's all from me, and thank you.